Good afternoon, everyone. Welcome to Inform Southeastern Michigan Distinguished Business Analytics Speaker event. I'm the President, Sarah Liu. It's my pleasure to introduce our speaker today, Professor Dmitry Ivanov, who is a professor of Supply Chain and Operations Management and the Deputy Director of Institute for Logistics at Berlin School of Economics and Law. His main research interests are the ripple effect control in supply chain structure dynamics, scheduling problems in Industry 4.0, and the digital supply chain twins. Professor Dmitry Ivanov has around 330 publications with 87 papers in prestigious academic journals, and the leading books Global Supply Chain and Operations Management, Structural Dynamics and Resilience in Supply Chain Risk Management, and the Handbook of Ripple Effects in the Supply Chain. He is a recipient of several Research Excellence Awards. Professor Dmitry Ivanov is leading working groups, tracks, and sections on the digital supply chain risk management, and resilience in global research communities. He is the editor of International Journal of Integrated Supply Management, associate editor of the International Journal of Production Research, and the International Journal of System Science, and a guest editor in many prestigious international journals. Professor Dmitry Ivanov is chairman of IFAC TC 5.2 Manufacturing Modeling for Management and Control, General Conference Chair of 9th IFAC MIM 2019 Conference, IPC and advisory board members of over 50 international conferences. Please join me to welcome Professor Dmitry Ivanov.
Yes, so thank you for your kind introduction. I would like to thank Dr. Oleg Gusikhin from Ford Motors Company for inviting me for this webinar, and Dr. Jason Liu from University of Michigan for organizing this webinar. So hello everyone, welcome, and thank you for joining this webinar. Hope everyone is safe and healthy. And today I would like to share some thoughts and ideas about ripple effects in supply chains at different pandemic stages. More specifically, we are going to look at how simulation and optimization can help predicting the impacts of and recovering from the COVID-19 pandemic. The agenda for the webinar today looks like shown in this slide. We will start with some major definitions of what is ripple effect and how it is specific currently amid the pandemic and during the recovery after the pandemic. After that, we will look into simulation of two cases which are related to different pandemic stages. On one hand, we will look at decision-making for predicting the impacts at the beginning of a pandemic. And after that, we will look at the recovery stages when we will hopefully come to the recovery and post-pandemic world, some interesting effects that have been observed by simulating with real company data. And we will summarize the theoretical and practical insights for a pandemic setting. And afterwards, at the end, I would like to offer some future research directions for discussion like digital supply chain twins, or how visibility and supply chain mapping can help guiding supply chains through different pandemic stages, and to discuss some basic features of a new concept, which is named viable supply chain. So to start, the outbreak of COVID-19 and the associated global pandemic has clearly shown the key role of supply chains in securely providing goods and services to society, and the key role of resilience to secure supply chains themselves, right? So, and of course, it's a very broad topic, supply chain resilience in the current situation. And I would like to focus on one particular aspect, which is a primary stressor of many supply chains and the subsequent collapse, disruption propagations, so-called ripple effect. So I suggest to organize the discussion today according to WHO classification of pandemic stages. So WHO has a kind of classification of pandemic dynamics, which begins with anticipation, early detection, containment, control, mitigation, and eliminations. And so we are going to understand the ripple effects at all these different pandemic stages. Afterwards, my plan is to discuss some major operations research theories and the resulting managerial insights. What do we already know on how to cope with the disruption propagations, and how the existing knowledge can help in coping with ripple effect now and in future. So let us start. Now, nowadays, we are experiencing unprecedented challenges and transformations in all areas of our life, and of course in supply chains, perhaps unlike anything in recent times. So here I'm just offering a few examples of pandemic impacts on supply chain resilience. So the questions which most of us are now asking, and both professionals and scholars. So one kind of questions can be, can traditional resilience assets like risk inventory or capacity buffers or backup supplies help at the pandemic settings? Or another question, is a localized supply chain more resilient? And what is the future of the global supply chains, right? So another question which is frequently raised is, should we change a paradigm from design for efficiency, as we currently have in most of the network optimization models, with objective of cost minimization, to paradigm of design for resilience? Another issue is directed to digitalization, to digital technologies. Are supply chain with digital twins, visibility, analytics technologies more resilient? What is the value of these technologies? And one specific aspect is disruption propagations, which seems to be one of the major stressors for supply chains. So this webinar, it's particularly about this question, disruption propagations in the supply chains at different pandemic stages. So to start with, supply chain resilience, just to recap, is a firm's capability to withstand, adapt, and recover from disruptions to meet customer demand and ensure some target performance. Right, so disruption is usually an event which is not planned or anticipated and may affect the structure or dynamics of systems. So usual examples which have been widely considered in research and practice are natural disasters, labor strikes, legal disputes, some economic shocks. And nowadays we are experiencing one specific type of disruptions, which is epidemic outbreak and even a global pandemic. And in this setting, nowadays, the role of resilience became as important as probably never in the last decades. Resilience is a kind of immune system of a supply chain. Each human being has an immune system in order to protect and recover if we become sick. And the same in the supply chain. So resilience, it's a kind of protection against disruptions and a way to recover once we have performance degradations, once we have structural dynamics and disruptions. So resilience is a very broad topic and one of the major research streams in supply chain operations management. Today, we are going to look at one specific aspect of resilience, which is the ripple effect. And to define the ripple effects describes the impact of a disruption on supply chain performance, disruption propagation, and disruption-based scope of changes in the supply chain structures and parameters. One can understand the ripple effect better if comparing it or contrasting it to the bullwhip effect, which is also very famous in our research community. So the bullwhip effect belongs to so-called high-frequency, low-impact risks, which is triggered by some small, more or less small variation of demand. It is a kind of operational or recurrent risk. Recurrent meaning it returns, it happens almost every day. We have demand fluctuations, we have lead time fluctuations. On the contrast, the ripple effect belongs to the risks which have low probability, high impact effects, right? The kind of exceptional risks, and the trigger of the ripple effect are severe disruptions, both in supply or in demand. So we can have backward and forward propagations of this disruption, but it should be a severe impact. And ripple effect refers to structural dynamics and describes propagation of disruptions and downscaling and demand fulfillment rates as a supply chain as a consequence of such a severe disruption. So this picture nicely illustrates the key ideas. So if we consider three supply chain structures at the beginning, on this left-hand side, everything is running smoothly. You can see the operational parameters are in the green area, and we are operating at according to performance targets in terms of service level, annual revenues, or any on-time delivery, any other indicators. In case of a disruption and a subsequent ripple effect, some of the nodes and arcs in our network can be disabled. Like, for example, we have a disruption in the second-tier supply, and since second-tier supply cannot deliver to the first-tier supply cannot deliver to the OEM, and this is a kind of disruption propagation which results in some destabilization of operations execution and degradation of supply chain performance. The next step is recovery. So with the case of some adaptations in structures or in operations policies, it becomes possible to recover. Hopefully, in most of the cases, it becomes possible to recover. And, maybe by changing the structures, by designing a new supply chain, and to recover the performance too. So, right. So more or less, we have here three stages: impact analysis, stabilization, and recovery. So now let us look at the ripple effect during the pandemic. And here we can observe a number of specifics which have never been observed before. So, of course, a classical example now is car manufacturing. Production stop at suppliers. For example, in China, end of January and February, the subsequent closing of ports, international transportation, and with some gap, with some time lag, beginning of March, mid of March, production stops at OEM worldwide. So this is a ripple effect during the pandemics. These ripple effects have some very specific features. It is more or less unprecedented vulnerability which we experience now. Unprecedented vulnerabilities in lead time and order quantities, disruptions in the whole networks, and severe demand fluctuations. So we have at the same time supply and demand disruptions. And just to bring some data, a recent survey of ISM, Institute of Supply Management, the data comes from middle of April, shows that average lead times are currently about 200% as compared to normal, say, prior to pandemic operations. And Chinese and European manufacturing companies are now operating at about 50% of their normal capacity maximum, right? In some cases, much less, 30% maybe. So, and this brings specific features of the ripple effect in the midst of the COVID-19 pandemic. Three features can be identified. The first one is a long-term existence of disruption, and it's unpredictable scaling. And this is understudied area in the ripple effect research. The second feature is simultaneous disruption and epidemic outbreak propagation. So at the same time, we have uncertainties in disruption propagation and in epidemic propagation. This is a completely novel setting which is concerned with the timing of the ripple effect in terms of simultaneous or sequential openings and closures of supplies, facilities, and markets. A very complex setting. And the third specific feature now is simultaneous severe disruptions in supply, demand, and logistics infrastructure. So this is also a completely novel setting where we have both forward and backward disruption propagation. So now let me discuss the state of the art in operations research methods for coping with the ripple effect. The ripple effect is actually an area which attracted a lot of attentions over the last decade. The existing studies can be classified into three areas, which are network and complexity theories, mathematical optimization, and simulation. So network and complexity theories are represented by Bayesian networks, complexity theory, entropy analysis, reliability theory, Petri nets, and Markov chains. If we look at the existing research on ripple effect from the mathematical optimization perspective, here we have three major methods which are mixed integer linear programming, with some algorithmic realizations with heuristic methods mostly. Then we have robust optimization research works and stochastic optimization. And looking at simulation, three simulation methods can be encountered when looking at ripple effect research, which are agent-based simulation, discrete event simulation, and system dynamics. So I was trying to summarize the major theoretical outcomes from each of this level and came up with this view. So network and complexity sciences are mostly looking at associations between network structures and risk propagation. Right? So it's more about analysis of critical network elements, modeling some interdependencies in the supply chains, sometimes with consideration of state dynamics, for example, using Markov chains, and a good portion of studies looking at the assessment of supply chain robustness and resilience to ripple effect. The process level, which is mostly represented by mathematical optimization, it's about, so most of the studies here are about optimal reconfigurations of material flows according to some disruption propagation scenarios. So these studies are looking at the impacts of the ripple effect and structural dynamics on service level and costs. And the results are usually optimal reallocations of demand and supply under conditions of disruption propagation and structural dynamics. And finally, looking at control level, we can see that most of the studies here are looking at impacts of disruption propagation on service level, inventory levels, and costs. The major specifics of this area are time-dependent effects, which are revealed in disruption propagations and supply chain behaviors in dynamics. Right? So here, for example, using agent-based modeling, the researchers are looking also at individual behaviors of firms in the supply chains. Sorry. Looking at the managerial insights, what can practitioners learn from this research? We can identify the following major themes. From the studies on the network and complexity science, the supply chain managers can use these results for identification of disruption propagation scenarios, just to identify what can happen, how disruptions can propagate some scenarios, and look at different severity also depending on risk aversion of a decision maker. Such models can be used for stress testing of supply chain design, proneness to some disruption risk propagation. These methods can also be applied for identification of critical suppliers and facilities for maintaining of supply chain operations, just for enabling supply chains to exist, and also adaptation of supply chain designs according to some changes. Looking at the process level, these results can be used by managers for stress testing of production distribution plans within some disrupted network designs, to analyze contingency and preparedness plans, and also to select optimal recovery plans. And in the control level, simulation results can be used in practice for analysis of disruption propagations in dynamics with considerations of some time-dependent issues like production, inventory policies, and it's also a convenient way to simulate operations policies during the disruptions, in transition to recovery, and in the post-recovery periods. Especially the post-recovery period can be very interesting, and we will look at some experiments a bit later in this webinar, especially about the transition to recovery and post-recovery period. Well, so far to the theory, and to exemplify, I suggest looking at two case studies, two simulation case studies. So the first one is shown on the screen, which represents a global supply chain with some manufacturing sites in China, with 3 major distribution centers in Europe, in the United States, and in Brazil, with some regional distribution centers in the United States, and a lot of customers worldwide. We have done, so based on this setting, we have done some simulations for 3 scenarios, and these are results of a recent paper published in the Transportation Research Part E. These 3 scenarios are depicted in this slide. So the first scenario is disruption only upstream. So disruption is localized in China, and there is no propagation. So in this case, only supplier, producer, and port are affected. And we tested this for 3 different durations: 45 days, 60 days, and 90 days. These numbers are coming from real example of the COVID-19 pandemic. So looking at statistics, some factories in China resumed their operations after 45 days at some small scale, some of them after 60 days, and some of them after 90 days. Then we had the second scenario, disruptions in the overall supply chains, in the upstream part and the downstream part. And again, we looked at different speed of propagation. For example, if quarantines and lockdowns downstream begin, say, in 30 days after upstream disruption, or in 60 days, like it's also based on the reality. If we look at the timeline of the COVID-19 pandemic, the quarantines and lockdowns in the United States, in Europe, began in about 45, 30, 60 days after the epidemic outbreak, or after the huge impacts of epidemic outbreaks in China. And then we also looked at different durations of quarantine times and lockdown times downstream, estimated them at a short lockdown period like 45 days, or long lockdown period of 90 days. And then we looked at the third scenario, the most severe one, where we have both supply and market disruption. The logic was the same: different speeds of disruption propagations, different durations of disruptions downstream, upstream. And this resulted in quite a few scenarios which were tested. And here I just want to share with you some of the results which can depict some interesting observations. So here, for example, we can look at the scenario in the line number 5, at the line number 8. Both of these lines refer to scenario number 3, where we have both supply and demand disruptions, right? For example, line 5 says that disruption upstream 45 days. In 1 month, disruption begins downstream, and this downstream disruption is of 45 days. And at the same time, during these 45 days, we also have demand drops by 50% in the markets. And under given scenarios, the model says that our supply chain would have on-time delivery of 82%. The revenue would drop as compared to the ideal scenario, but not so drastically, actually. And our profit would also, of course, drop significantly if compared to the initial scenario, but still we are making some profits and not too low, right? And if we then look at the scenario number 8, what the difference is that disruption duration upstream, it's now 60 days as compared to 45 days. All other parameters remain the same. Propagation speed 30 days, demand decrease 45 days, and production disruption downstream 45 days. And here we can actually observe that there is not much difference, or almost no difference in revenues, in on-time deliveries, and in profit, despite of the increased disruption duration upstream. All right, so here we can state the first observation. Despite the increase in disruption duration upstream, there is almost no difference in the performance impact in the case of relatively fast disruption propagation of 30 days. But now if we look at the lines number 5 and number 6, now here we have a bit different situation, right? So the difference between lines number 5 and number 6 is that disruption propagation is 60 days instead of 30 days. And this, say, slower disruption propagation results in bigger performance impact. Right? So the revenue, the profit it's less and significantly less as compared to the scenario number 5. So this is the observation which shows the impact of disruption of epidemic propagation speed on the supply chain performance. And exactly another comparison which we can do is if we look at lines number 7 and line number 11. Here we have two different cases. In line number 7, disruptions upstream and downstream happen sequentially, right? So first disruption upstream, then the factory in China is recovered, but after that we have disruption downstream and quite a long disruption. It is sequential disruptions. And in line 11 we have simultaneous disruptions. So long disruption duration upstream, and at the same time, say in 60 days, we have disruption in the downstream parts, so simultaneous case. And here we can see quite a depictive, interesting results. So in the case of this very severe scenario number 11, so it is the worst result. We don't have profit anymore. We are losing money. So, and this is the most negative scenario. In the scenario number 7, we are still profitable, right? And the difference between scenarios number 7 and number 11 is sequential or simultaneous disruptions. So we can have here now interesting effect of timing of disruption propagation, right? Timing of facility openings and closures at different echelons of the supply chain. This might have quite a high impact, right? And this is how we compare two scenarios, so two scenarios from the previous tables. The first one is 45 days of upstream disruption, 60 days delays in epidemic outbreak downstream, and 45 days downstream disruption. And another one is different, so that we have 90 days downstream disruption. So the first two parameters are equal, 45 days of upstream disruptions in 2 months, begin of epidemic outbreak downstream, and this disruption lasts 90 days. And we can observe significant differences in performances, right? If we look at service levels, if we look at financial performance, and also if we look at the lead times, right? So we can observe that longer disruption downstream can have significantly more negative impacts on supply chain performance. It is also seen in the production inventory dynamics, as compared to shorter lockdowns, in the downstream disruptions, which allows the supply chain to recover faster. And now I just want to show you some simulations which can be done in this area. So what we have seen now on the slides, we can try to observe live, right? So this is our supply chain and the connections between them. So the data which we have demand for different customers. We have inventory processes like reorder points up to level policies. We have some sourcing policies, and we also have disruptions. So as here we are setting disruptions as events. On the 25th of January, disruption upstream, which would last 45 days. In 60 days, begin of disruption downstream, and this disruption downstream would last 45 days. So, and now if we are looking at the simulations, we can see how this disruption impacts can be observed in dynamics. It can be observed in dynamics. So now we can see that, so we are now in the beginning of January and everything looks fine. Our factories are working perfectly and delivering goods to distribution centers worldwide. So, and now if we look at the 25th of January, the factories are disabled in the simulation, and there is no material flow, unfortunately, right? So the supply is broken, and distribution centers are still working because of some risk inventory and some in-transit inventory, so risk mitigation inventory. They are still working, they are delivering to the customers, but they are not receiving, of course, goods from the factory in China. So that has speed up a bit the simulation. So now we can see that the factories are now active. They started the production, which is great. Right? So but now the distribution centers are disabled. So on the 1st of March, end of March, somehow end of March, say some lockdowns, quarantine times in other regions of the world began, and so we can have that some severe interruption in the supply chain. Now we are end of May, according to this scenario, everything is working again smoothly and we are recovering. So now let's take a look at performance. As we could expect, the service level decreased significantly. For some period of time, we could maintain service level because of risk inventory, because of some safety stock, but then of course it drops, and now we are recovering So we are slowly recovering, and we can also see that our lead time is quite fluctuating, right? We have fluctuations of the lead time according to this disruption. So this is, so the models behind these results is also allowed to observe in dynamics such ripple effects in global supply chains. So, well, now let me switch back to the presentation. And summarize our observations. Right? So the first observation is that supply chain performance reaction depends on the timing and scaling of disruption propagation, and also on the sequence of facility closing and opening in different supply chain echelons. The next observation is that a combination of velocity of pandemic propagation, the duration of quarantines and lockdowns of production, distribution, and markets, and the degree of demand decline. This setting is very severe and very specific for ripple effect under pandemic. And then we have the different components of a supply chain can be affected sequentially or simultaneously with some overlapping time windows. This is also a novel effect in the ripple effect area observed here. So, and now let us look at the very fast, very short case study 2, which refers to recovery and post-disruption time. Here we did some simulation actually in the last year, and 2 years ago, so much earlier as pandemic started. And this case was about disruption of a distribution center, which was a real life case, disruption for 6 months in a supply chain with 4 markets. And unfortunately, this disruption happened in the market where factory has been closed because of some network optimizations based on the cost minimizations functions. So in terms of efficiency, it was probably the best way, but in terms of resilience, not so much. And we simulated what happens in this supply chain and observed quite an interesting effect, which we named disruption tail. So the disruption tail has been observed after recovery of capacity, right? Here we have capacity area which was disrupted to 50% for 6 months and recovered. However, if we look at the post-recovery case, post-recovery period, we can observe misbalancing of inventory and production processes with huge peaks and backlogs during this period. And we named it as disruption tail. So the reason for this disruption tail is a backlog that was accumulated over the disruption time. If this backlog is now transferred to the post-disruption time, of course, production inventory processes became unbalanced, right? And even after capacity recovery, inventory peak and further destabilizations can be observed. This is quite an interesting effect, which some companies could consider now when approaching the recovery post-pandemic stages, to think about this backlog and other inefficiencies which were accumulated during the quarantines and lockdown times to avoid this disruption tails, transitions of these residues into post-disruption period. Right. So one way to resolve this problem is information coordination and visibility. Right, so we simulated the same system with information visibility and coordinating data about backlogs and adjusting ordering rules in the post-disruption period, and it works very fine. Here we can see that no disruption tails are observed. So another insight on the value of visibility. So far to the insights I wanted to share with you. And at the end, just let me a couple of minutes to discuss some possible future directions which can arise in the area of the ripple effect. So here I suggest to look at 4 areas which are digital supply chain twins, viable supply chain, intertwined supply networks, and multi-structural dynamics. So the first promising research avenue is related to digital supply chain twins. So digital supply chain twins, it's a kind of real-time model which represents a real supply chain with its complexity and allows to support decision-making in a number of areas. It is a kind of mapping, risk data mapping and supply chain model mapping and simulating performance impact of some disruptions. Right, so using historical disruption data and real-time disruption data, the digital twins can support and mitigate the ripple effect by stress testing of some supply chain designs and selecting recovery plans. And such digital twins are also convenient to analyze possible performance impacts and also to analyze real impact of performance if we are operating under disruption, like now under pandemic. Another directions are intertwined supply networks. If we look at real supply chains in practice, we can observe that supply chains are usually intersecting with other supply chains, right? So buyers and suppliers can be represented by the same firms. The company which is buyer in one supply chain can be supplier in another one. Just an example, suppliers in the automotive sector are at the same time producers of valves for respirators. So here we have 2 intersecting supply chains, automotive supply chains and healthcare supply chain. And as such, it can be interesting to identify mutual synergies and develop a kind of ecosystem view on intertwined supply networks. The next direction, which I would like to offer for discussion as a possible research avenue, is viability or viable supply chain. So viability can be defined as ability of a supply chain to maintain itself and survive in a changing environment through a redesign of structures and replanning of performance with some long-term impacts. Recently we suggested a viable supply chain model which is based upon adaptable structural supply chain designs for supply-demand allocations. And most importantly, establishment and control of adaptation mechanisms for transitions between the structural designs. So just to consider an example, a supply chain can have 3 structural levels: agile supply chain, resilient, and survivable. Right? At the normal times when everything runs smoothly, we should utilize advantages of lean, agile responsiveness to maximize profitability. In the case of some singular disruptions, the second structure, resilient structure, can be activated, which uses risk inventory or capacity buffers or backup supplies. And in the case of very severe long-term global disruptions like a pandemic, the third structure, survivable supply chain, can be adapted with the help of production changeover. Like we observe now, car manufacturers are producing ventilators, or companies which are usually producing luxury clothing are now producing masks. So redesign of supply base is required here, and redesign of logistics. So a kind of multi-structural supply chains and adaptations according to different stressors, like multi-level view. And in developing this multi-structural view, the last interesting research comes from understanding that ripple effect is not only related to organizational structure, right? So many research papers are written about the impact of ripple effect on organizational structure, the structure of companies. But if we look at now at the pandemics, we can see that not only structure of companies is changing, we also observe changes in the product structure. Like we are producing cars and suddenly we are producing ventilators, or we are producing luxury perfumes and then we are producing sanitizers. So this also implies changes in the process structure, in the technological structure. Of course, we need other suppliers and other logistic structures. The subsequent changes happen in financial structure and of course also in the information structure. So this is another interesting issue on how to understand this multi-structural aspects of ripple effect. In this area, I would like to point to new special issue in the International Journal of Production Research on viability of supply networks and ecosystems, lessons learned from COVID-19 outbreak. The deadline for submission here is, I guess, in November this year. Okay, to summarize the insights from this webinar, we looked at 5 stages of a pandemic, which are anticipation and early detection, which are aggregated here just for better visibility of this slide. Containment, control, mitigation, and elimination. And here we can identify a number of managerial insights and future research suggestions according to each of these stages. Right? So, for example, at the anticipation and early detection stage, it's about enabling preparedness, supply chain mapping, visualizing supply chains to identify disproportional changes in demand and supply. At the area of containment, it's more about stress testing of existing designs, alternative topologies, predictions of the ripple effects. Right? His supply chains already experience structural dynamics. At the control and mitigation stage, it's about deployment, realization of operating policies under pandemic. You can name it pandemic plans of supply chains. And here we have a number of future research suggestions to understand the role of pandemic timing and scaling for the ripple effect. Because here we are mostly concerned about adaptations and supply-demand reallocations. And looking forward, looking in the near future, I hope it is now a near future elimination stage, here the major managerial insights is to avoid disruption tails and future research area of supply chain viability in order to ensure adaptation of supply chain to post-pandemic environments. Well, so my summary looks like follows. So ripple effect describes disruption propagation in the supply chain, which is one of the major stressors of supply chains during the COVID-19 pandemic. Operations research techniques offer a large variety of methods to support supply chain adaptations through a pandemic and thereafter, especially network and complexity theories, mathematical optimization, and simulations. We identified 3 specific features of ripple effect under pandemic, which are long-term disruption existence and its unpredictable scaling, simultaneous disruption propagations and epidemic propagation at the same time, and simultaneous drops, disruptions in demand and supply. And another observation was that exiting a pandemic can be even more challenging as entering it. So, for example, danger of disruption tails. Looking in the future, there are some interesting, exciting research directions, like to transit from offline modeling to data-driven digital supply chain twins, and to think about viability of supply chains and intertwined supply networks. Just thinking beyond traditional resilience understanding as a recovery of some critical capabilities from economic performance of view, and organizing the debate towards viability and more complex supply chain networks. Thank you very much for your attention, and I will be happy to answer your questions.
Okay, thank you very much, Dr. Ivanov. I have received many questions. I will try to forward you some general questions first. Then if time allows, we can answer some more specific questions. Okay, the first question is that for design at network level, how to balance redundancy and efficiency, how to balance between lean and resilient supply chain. As we know, lean approach makes supply chain more sensitive to disruption.
Fantastic question. This is one of the fundamental questions here. And if we look at the analysis of the ripple effect at the pandemic times, it is more about this trade-off between efficiency and resilience. Right? So most of us are looking at lean supply chains, at single sourcing, at low inventory as major roots of these collapses, which now happen with many supply chains and reasons for the ripple effect, right? And this is the question: should we invest more in the resilience, or should we, allow some risk? Of course, each company would answer this question depending on its strategy and a lot of different factors. So we actually published a very specific paper about this topic, which is named Low Certainty Need Supply Chain, Efficiency versus Resilience. Right? So, and we came up with a concept, resilientness, resilient plus lean. Indeed, there are some ways to remain lean and at the same time to increase resilience. So these ways are both operational and informational. If we look, for example, at operational levels, we know that distribution network design can help to reduce transportation costs in the supply chain, so to increase efficiency, right? If we increase the number of warehouses, if we shorten the transportation routes, we can have scale effects in transportation. And at the same time, we know from resilience that more distribution centers, it's more resilient. So at the same time, we have some backups, right? So at the same time, we have both lean and resilience in one decision. And we can also look at visibility, right? Visibility can help companies to become, to improve efficiency, to reduce inventory, visibility. It's very useful for lean, and at the same time, visibility is incredibly important for being resilient. So this is a fantastic question. It's a very interesting research direction to search for ways, for possible methods to be both lean and resilient.
Okay, thank you very much. The next question, are there any specifics of the ripple effects during the pandemic as compared to the normal times?
Yes, it's one of the most important questions now. And I will say yes, we have a lot of specifics here. For example, you can look at the disruption duration. Right? So if you look at say, traditional disruptions like natural disasters, they happen, they disappear, and this period of time is relatively short. But now we have a disruption which already took a couple of months, and nobody knows how long it will be, and what is ahead of us. So the scaling is also unpredictable. Then we have a specific that we have both supply and demand disruptions at the same time. This never happened before in the ripple effect analysis. And one additional specific comes from timing of facility openings and closings, right? Because of globalization, for example, because of global supply chain facilities are located in different geographical regions. And because of local regulations, because of local decisions on quarantines or lockdowns, introduction duration, facilities in the supply chains can open and close at different times. So this timing of opening and closure is very specific issues of the ripple effect and pandemic time. So I think these issues, but maybe there are some more which could and should be identified in near future in the research on the ripple effect.
Okay, thank you. The next question. The pandemic will have greater impact on companies following just-in-time JIT approach compared to companies following the large inventory approach. So will more companies switch from JIT to large inventory?
Okay, it's also a very good question. So having inventory is good for resilience. With that said, it is important to have inventory at the right place, right? So it is not automatically that a just-in-time company would be more prone and less resilient as a company with huge inventory. In case if this huge inventory is located somewhere where we have a disruption, if we have no inbound, no outbound logistics to this inventory, there is no value. No, and that's why, and again, we can have a company with some local just-in-time relations, and this company can be even resilient in some settings. So I guess there is no general rule for this setting, and it depends on the timing of disruption, depends on the scale of disruptions and availability of logistics to access this inventory.
Okay, thank you. The next question. What is your opinion on diversify global supply chain and reduce dependence on few countries? Will localization work better?
Yes, it's also a fantastic question, and I guess this question is now being discussed almost in each talk about supply chain resilience and ripple effects. So again, it is not automatically that a local supply chain will be more resilient as a global one. Right, so I guess we can expect a number of exciting research in the next months and the next years about if we should praise local resilience, about global efficiency. Right? It was a fantastic webinar of Professor Christopher Tang on this issue of future supply chains. So here there is no automatic rule, and if local supply chains are more resilient. So my perception is that for some period of time, especially now and in the next months, it can be a trend for localization, especially using digital technologies, robotics, additive manufacturing. We can observe now, for example, there are some statistics, some data for Europe, for France, for Germany, that companies are starting to buy more robots because they are not so expensive as some years ago. So they became more affordable, and even medium-sized enterprises can buy robots, and this can lead to some localization of production for some period of time. But at the same time, I think if the situation is normalized, the companies will continue to utilize advantages of globalization, advantages of the global supply chain, and perhaps we'll have a kind of combination, some hybrid systems, again, triggered by developments in additive manufacturing, in robotics, in information technology, and digital technology, which can increase the localization degree of the supply chain. But it is a combination. It's a combination of localization and global supply chain, which will probably happen.
Okay, great. The next question, which OR methods are most popular for ripple effect analysis, and what are the research gaps?
Yes, so if you look at the ripple effect, we should also look at similar concepts like systemic risk and cascading effect, disruption, propagation. This research became a visible stream in literature, and I guess the first works were published in about 10 years ago, and especially in the last 3 years, the number of publications increased exponentially, and it is increasing further. So if we look at the methods, we can see a big interest into network analysis, into complexity theory, to analyze ripple effect at a micro level, to understand network dependencies, different supply chain designs, and their proneness to the ripple effect. Then there is an important stream of mathematical optimization where we break down discussion to protection and recovery policies to reconfiguration of supply and demand in case of disruption propagations. And then we look at simulation studies which bring dynamics, right, allow time-dependent aspects to be analyzed. And research gaps can be seen in different areas. So I guess the current state of the art allows to understand ripple effect at macro level, and future research could take more granular view to envisage some some detailed explanations, testing for different industries, for different case studies, to understand specifics, detailed, focused specifics of the ripple effect in different industries, in different settings. For example, in pandemic setting or in natural disaster setting. This is an interesting issue. Another interesting issue is a combination of backward and forward propagations, right? Most of the studies on the ripple effect are looking at forward propagation, disruption upstream and propagating downstream. At the same time, as we have now in the pandemic time, there is also backward propagation, huge demand disruption and impact of this demand disruption on the upstream parts. This area is definitely underexplored and deserves more attention.
Okay, thank you. Due to a time limit, I will forward one more question. Actually, there are several technical and more detailed questions. For those of you having the questions, you can contact Professor Ivanov individually via email. The last question is, what is the relation between disruption tail and the bullwhip effect?
Oh, excellent question. So the major difference between the bullwhip effect and disruption tails can be seen in the trigger of this situation. The bullwhip effect is usually triggered by small demand fluctuations, right? And the disruption tail is a consequence of a severe disruption, right? So at the same time, I would certainly see a number of intersections between bullwhip effect and disruption tails, right? And moreover, we recently published a paper which exactly tackles this issue. Can the ripple effect cause the bullwhip effect? So, and we have observed in this paper that under some settings, indeed, the bullwhip effect can be a consequence of the ripple effect, right? So this is a very interesting question, and I would actually see it as a promising research direction to combine operational risks and disruption risks to see, to observe, to examine intersections between the bullwhip effect and the ripple effect.
Okay, thank you very much, Professor Ivanov, and thank you all for attending the webinar. The webinar is recorded, and I will share the video on Inform's social media and share you with the link. In case you cannot find it after 2 days, you can contact me individually. Okay, thank you very much, and stay safe and stay healthy. Bye-bye.
Thank you very much. Stay healthy, be well. Bye-bye.